Essentially, all of today's chemicals and materials, from plastic bottles to vitamins, are made from the oil that we dig out of the ground. Unfortunately, the use of this oil has resulted in an increase in energy demands, higher prices, and climate change. This has motivated a growing need for greener and more sustainable methods of producing fuels, medicines, and specialty chemicals. I'm Ashti Karim, a chemical engineer developing a major shift in the way that we address these problems, going beyond the traditional use of bacteria. Now, normally you'd think that bacteria are bad. And while there are some bad bacteria that cause disease, there are also good bacteria, like the bacteria in your gut that digests food. Scientists have learned to manipulate good bacteria to make products from simple renewable starting blocks for centuries now. Some of the oldest examples include the use of yeast in the fermentation and leavening of food and alcohol. So bacteria can effectively be treated as miniature chemical factories to produce these products. But the process of developing and engineering bacteria is expensive and time-consuming. The fact is that there's a tug of war between bacteria wanting to grow and us wanting them to make a product. And while we've gotten good at harnessing biology, bacteria still can't make enough product, and the products that they can make are limited. My research involves cell-free systems in which you can cut open bacteria, remove the walls of that miniature chemical factory, providing direct access to the machinery within. With greater control over the bacterial parts, we can conduct precise chemical synthesis without intact bacteria. This could accelerate the development of biodegradable plastics, biofuels, or even medicines. We can also prototype or test out different bacterial parts together in new ways from one or multiple bacteria, or even in combination with parts from scratch. We can test out all possible combinations in a fraction of the time that it would take with live bacteria. This could even lead to the discovery of new parts or new products. Characterizing and engineering bacteria in this way provides an efficient method to design, build, and test systems to make new fuels and other chemicals. You could even imagine making products that were impossible by chemistry or biology alone. It's a little crazy, but I even envision a world where we can make all of our material items from bacteria. Wouldn't that be something? Cell-free systems could pave the way to make the products we buy greener, better, and cheaper.